For the August in the Taiwan region, we actually have northeasterly anomaly. That means the weak southwesterly flow. And also you see a yellow color. That means the relatively weak convection. So we were actually in an environment that's not favorable for the development of the huge convection. Then you look at the system temperature. It was quite warm. We already know that. That's one of the very interesting El Nino phenomenon. And okay, so we got some warm SST in, for example, linear 3.4. So I simply did a very simple calculation, calculated the correction coefficient between the linear 3.4 and the vertical velocity at 500 millibar. And this is the figure we got. So there's no doubt you can get more upward motion over the linear 3.5 area and 0.4 area, and also in the southern part of Philippine Sea. But in the Taiwan area, you got yellow color again. That means although it's not very huge correlation, but that means it has a tendency to produce a downward motion anomaly. Or at least it means that the upward motion should not be strong. Okay, so the last years, based on this very straightforward, simple calculation, probably implies that whenever we have this kind of condition here, it's probably not particularly favorable for the development of convection near Taiwan. So probably El Nino is one of the factors. And if you look at the rainfall distribution in Taiwan, this is the one station called Tainan, southern part of Taiwan. And this is the accumulated annual rainfall. So if you look at this blue curve here, Tainan received very little rainfall compared to the climatology. Okay, a great deficit. Then came the Typhoon Morakot. Then the accumulated rainfall reached the actual amount of the, or slightly larger than the climatological number. Then after the Typhoon Morakot, there was no rainfall. Again, virtually no rainfall. So even with the huge rainfall brought by the Typhoon Morakot, the annual rainfall was still that much less than the climatological number. And if you remove the rainfall produced by Morakot, because most of this rainfall was not kept, it was going into the Taiwan Strait. It was gone. It was not kept on the land. So if we remove the Morakot's rainfall, this is the rainfall we got. Less than half, probably slightly over 1/3. So this happened in many stations in Taiwan. Okay, this is the percentile of annual rainfall for 2009. And look at Tainan here, it was 31 percentile. And for the Danshui, northwestern part of Taiwan and southeastern part of Taiwan, here is you got 5 percentile. And in the eastern part, very near to the Chinche's hometown, only 50 percentile. Okay, so only those areas in the mountains and the eastern part of Taiwan, you will see above normal rainfall. So it's probably quite fair to say it was almost a drought for Taiwan in 2009. And we tend to forget that because the Morakot event. And okay, then let me talk a little bit more about this long duration and record-breaking rainfall. So when Morakot approaching Taiwan, for example, on the 6th of August, we have a rainfall over northern Taiwan. Then when it comes into Taiwan, the rain band actually comes southward. And by the time of 8th of August, here you see there's almost stationary rain band near southern Taiwan, and at this time, this particular day, produced a huge amount of rainfall continuously, and that's why it caused so much damage. And this is the total rainfall for I forgot the exact day, 3-day or rainfall accumulation. So for this area, the rainfall amount exceeding, I cannot see that here, probably more than 2,000 millimeters. So the biggest rainfall area concentrate on this sloping terrain area to the west of the central mountain range. And this subtable, I'm sorry, I apologize for it was still in the Chinese version. But here I put some English word here for example, Alishan that received the largest amount of rainfall between the 6th and the 10th, and that the rainfall exceeding 3,000 millimeters. Okay, so actually producing, most of the rainfall was produced in 2 days. Sorry. And let's compare with some other previous events. Okay, here again it's in Chinese, sorry. So here's a historical record for a 24-hour accumulated rainfall. And the first one still go to Typhoon Morakot. Okay, that 24-hour is slightly less than 1,750 millimeters. And Morakot was almost 1,600. So and this the first 5 or first 6 largest rainfall produced by Morakot. So actually, you compare this table here, and the first 5 here can become the 2nd to the 6th in the record. Okay. So, but for the 48 hours, it actually broke the record because for her, it was less than 2,000 millimeters, but for Morakot, it exceeds, what's the number? It exceeds 2,200, sorry. It sounded a little bit too large, right? That's certainly a world record or universe record. And our understanding why we produce so much rainfall, one of very important mechanism or factor was the weakening of steady flow when the typhoon approaching Taiwan. It reduced its translation speed reduced from 20 km per hour to 15 and to 10 to less than 10 when it was over Taiwan. When it was curving northwestward, you see the closer dot here. Okay, so that was the main reason